Lesson 38, dividing polynomials using long division. We are also going to learn synthetic division. That's the short way that I was talking about. So we're just going to jump right into examples, by the way. Example 1, it says divide these two terms. So the first one that they give you says divide 3x into, and then they give you this really long polynomial, which is 12x to the third minus 6x squared plus 5x plus 4. Now, this always has to be in standard form, which means in decreasing order of magnitude. If you don't have it in decreasing order of magnitude, it's going to be really, really hard to do properly. So put it in decreasing order of magnitude. If this did not have a x squared, I would put 0x squared in for it. Okay? And I would still have to follow along. So long division works better for single term problems. On single term problems, you want to use long division. Okay, so this one will be the example we use long division for. And it goes just like we did when we were younger. We would say, I don't know, what is 3 divided by 200 and, let's say 343. Okay, I would ask myself, 3 goes into 3 how many times? Once.
11.
Once.
Wait,
And then I'd go,
you said 33, I'm sorry.
and then I'd ask myself, 1 times 3 is 3, and I subtract, right? And I get 0 and drag down the next number. And then I ask myself again, 3 goes into 4, how many times? Once. 1 times 3 is 3, and I subtract, which gives me 1. And then I drag down my next number. And I ask myself again, right? So that works this way every single time. And when I get to my final one, I say 3 goes into 13, how many times? It goes in there 4 times. 4 times 3 is 12, subtract, and I have 1. And I would have a remainder of 1, or I would write it as 1 over my divider, which is 3. Okay? So this will work the exact same way, but now, of course, we're using variables. So here I ask myself, 3x goes into 12x to the third how many times? So it goes in there 4 times to get the 12, but what do I need to multiply x by to get x to the third? So I get x squared.
Oh, it is.
Okay? I write it right here just so that I have my x squareds on top of each other. OCD kind of a thing, I guess. Okay? Is there any questions as to how I got from this to that? Okay. So when I multiply this, 3x and 4x squared, I should get my 12x. So I'm going to go back around this way. I go 4 times 3, which is 12, and then I go x squared times x, which is x to the third. And of course, I subtract it, just like I did over here. I'm left with 0, and I drag down my next number, which is negative 6x squared. Now, the way the book tells you to do it is to drag down everything each time, and you can. Well, just longer, because I have to write down everything every time. Then I ask myself the same question. 3x goes into negative 6x squared how many times? So negative 2, right? So negative 2, and then how do I get from x to x squared? I go x. So then I multiply it back around, I get negative 6x squared. And I subtract it. So negative and negative make a positive, right? And that becomes 0 again. And I drag down my next number. 5x is next. How many times does 3 go into 5? Goes in there 1 time. And how many times do I need my x to go in to change to an x? No, nothing, right? What? Did I write it down wrong?
Well, on the book, when it actually shows the top of that, it uses 6x.
Since we have 5x, we found out that it goes in there 1 time, 3 goes in there 1 time, and x only goes in there 1 time. But we don't need to write an x again, because then we'd end up with x squared. So it's just multiplied by 1. So 1 times 3x is 3x. We subtract it. This was positive. Sorry, I forgot to put my plus. So we subtract it, and I get 2x. And then I drag down my next number, which was plus 4. And of course, I'm down to this point where I go, this is my remainder. Okay? So just like I got down to this point, this is my remainder. So remember what we did with our remainder? We made it our numerator. So we're going to make 2x plus 4 our numerator and
Over 3.
3x our denominator. And if it's positive, which it is in this case, it's plus. If it's negative, obviously it would be minus. Okay? So that's the final division. If it said to just write it out as a, so you can get it back, or to check it, you would take your 3x and you'd multiply it by whatever you got for your quotient, which was 4x squared minus 2x plus 1 plus 2x plus 4 over 3x. Close parentheses. And then we just distribute this back out and we get the number that we started with, hopefully. So I get 12x to the third minus 6x plus 3x. Now this is the part where it gets harder, because I'm just multiplying this on the top, so keep that in mind. Okay, so it becomes plus 3x multiplied by 2x plus 4, right, over 3x. So that's nice, that cancels it out. So I actually have 12x to the third minus 6x, ooh, I forgot to write squared, x squared plus 3x, and then all I have left here is 2x plus 4, so plus 2x plus 4. And when I combine the middle, I got my 5x's. Okay? Not necessarily on the checking part of things, but did you have any questions on the actual long division? Yes. On the remainder, if you can simplify, would you? Yes. Example 2. Okay, this is dividing polynomials. So that just means we're dividing two things with multiple terms. So here they say you want to take x to the fourth plus 2x to the third minus 13x squared minus 38x minus 24, and we want to divide that whole thing, should have made that smaller, we want to divide that whole thing by x plus 4, x plus 4. Okay, so now that I have this all set up, I can do the same steps that I did the last time. So since I did long division on this one, I'm going to, with one term, I'm going to do long division with two terms, and then from then on out, we're doing synthetic division. So here I would ask myself the same questions that I did before. I'd ask myself, how many times will x plus 4 go into x to the fourth? Okay, so really all I'm looking at specifically is how many times what do I need to do with my x's? So what do I need to multiply x to the third? So I take my x to the third and then I multiply it back through. So keeping in mind that this both gets multiplied by x to the third, I'd go x to the third times x is x to the fourth, and 4 times x to the third is 4x to the third. It's positive in between. But remember, we're subtracting. So we subtract and we subtract both of those. We have to distribute out that negative. Okay? So we have two subtraction problems now. So this goes away, it becomes 0. But on the next one, this becomes a negative 2x to the third. And then again, I ask myself, I'm going to drop that down, sorry, 13x squared. And then again, I ask myself, what do I need to multiply this by to make the leading terms the same? So clearly, I'm going to have to multiply it by a negative 2, right? What is my x power going to be? X squared, right? And then I just multiply it back through. So negative 2x squared times x is negative 2x to the third. Negative 2x squared times 4 is negative 8x squared. And then again, I subtract everything. So these turn both into plus. So we're ending up adding them in the end. But this one, again, cancels out. And it should every single time. If it doesn't cancel out, then you're at your remainder. So on this next step, I have a negative and a positive. So different sign difference. The difference between 8 and 13 is 5. And it's x squared. And since this one is further away from 0, it is a negative 5. Yes, it is a negative 5. Then I drop down my next one, negative 38x. And I ask myself, how do I change this x to match this one? I multiply it by a negative 5 and x to the just regular, right? So, and then I multiply it back through. So I have a negative 5x times x, which is negative 5x squared, negative 5x times 4, which is negative 20x, and then I have to subtract it. So these both turn into pluses. Those cancel out. We have a negative and a positive, so different sign difference. The difference is 18. Negative 38 is further away from 0, so it's negative 18x. Drop down the next one. I have negative 24. I ask myself again, what do I multiply this by to match this one? And it is negative 18. So negative 18, stupid pencil. Negative 18 multiplied by x is negative 18x. Negative 18 times 4 is a number that I don't know off the top of my head. 72. Awesome. Minus 72. So again, I subtract these, so they turn into plus. That one cancels out. And we have the difference between 24 and 72, 48. And that one is positive, finally. So my remainder, because x doesn't go into 48, is 48. So I have 48, and since it's positive, I'm going to put a plus, over x plus 4. So my final answer for my division is that right there. And again, you can check it by multiplying them together and seeing if you get what's inside. So now you start to see why I'm not a big fan of long division. Okay. On example 3, you will either love me or hate me because I showed you the first method. I'm not sure. Example 3. They give us, and I want you to keep in mind this part. We're trying to divide a polynomial in standard form. Polynomial in standard form. And we're going to divide it by something in the form of x minus c. Okay, so c is the constant piece. So if it tells you to divide by x plus 5, you need to remember that your constant there is negative 5. Okay? If it says x minus 3, then our constant there is just 3. So you're actually taking opposite of your sign because in the original form it wants you to have a minus there. Okay? So now when I do my long division, your life gets somewhat easier. Here's the original equation. It tells us to divide 4x to the 4th minus x to the 3rd. And you should notice when you're looking at example 3, there is no x squared. So I'm just going to add a 0x squared. Okay, because that'll make that term go away because it's being multiplied by 0. But I have to fill that hole. Minus 11x minus 484. Okay, so what I want to do when I'm doing synthetic division is I find out what my divisor is. Okay, that was my little side note. It said divide, well, of course it would give me something big. It said divide x squared plus 11. For synthetic division, does this format fit our rule? No, because it's x squared, right? So it doesn't fit our rule. So what I'm going to do is just to show you how or what our answers will end up looking like. I'm going to show you synthetic division where we use, let's use x minus 2. Okay, so we're going to use this as our divisor to show synthetic division. If it fits this form, which is, it does, right, x minus c. What if it was plus 2? Then it would be minus 2 when we do our division. So since it fits our form, we would take our c, which is 2, and you do kind of like an upside down division bar. And we write the coefficients of each term. So here I have 4, negative 1, 0, negative 11, and negative 484. Now I take this and I ask myself the same kinds of questions. I'm going to drop down my first one. Okay, so I'm going to drop down my first one only. And I put 4 down here. And I start just multiplying everything through. Okay, so I take my 2 and I multiply it by my 4. I get 8. Ooh, man, I'm going to mess this up if I don't look back. Okay, so on the synthetic part of things, of course, the very first step was you drop down, right? So when we drop down, we start just multiplying down and popping up. So it'll go like this every single time. So 2 times 4 is 8. And then whatever the rules say, so if it's same sign, you add them. If it's different sign, then you need to subtract them. So since they're different signs, it's going to be 7, positive though. And then again, we do that multiplication. 2 times 7 is 14. Since it's just 0, and it's positive, 0 and 14 just make 14. And again, I do that again, which will make 28. And different sign difference, the difference is 17. Positive again, multiply it through, 34, go ahead.
So if the sign, like the negative 1 and the negative 1
Same sign sum. So you would do the rules. If it's same sign, you add them together, keep the sign. If it's different signs, then you take the difference between the two and keep the one furthest from 0. Okay. So for this one, it's different sign difference, and I'd get negative 450. So my numbers, if they didn't have lines all drawn through them, would look like this. Because we started out with an x to the 4th, it would be 4x to the 3rd plus, since that's positive, 7x squared plus 14x plus 17 with a remainder of negative 450. So I take my 450 and divide it by x minus 2. And that would be my remainder. I like synthetic division primarily because it takes up less room. It's quick, but I mean it takes up a lot less room. Okay. Now, if you're doing it with an x squared, you have to do long division. You don't have a choice. Okay. Saxon's nice about it because they normally make them work out easily, but you have to do long division if you're dealing with something with an x squared. But if you just get a regular old x, then you can go ahead and perform that division. Do y'all guys want to do another synthetic division?
Yes.
Okay. So let's do example 4a. It says we are dividing x plus 2 into 2x to the 3rd minus x squared minus 7x plus 6. Yes, in essence it would be the denominator part of it. So it's dividing. So we're going to do synthetic division this time. What is the number we are dividing by? It would be negative 2 this time. And I guess we'll just, you guys want to do the short bar or the long bar?
Long bar.
Long bar. Okay. Let's do long bar. And we go straight across. So I take the coefficients. Is it in standard form? It's already in standard form, so I can just take my numbers. 2, negative 1, negative 7, and positive 6. I drop my first term, which is just 2. And I start multiplying. Negative 2 times 2 is negative 4. Same sign sum. I get negative 5. Negative 2 and negative 5 give me a positive 10. Different sign difference. I get a positive 3. Negative 2 times 3 gives me a negative 6. Different sign difference, I get 0. So that 0 means I have no remainder. That's nice. So now I start out with an x to the 3rd, so I can just fill in. This is x squared. This is x. This is regular. So since it's positive, I'm just going to put a plus there. There is no remainder.
Why do you start with x?
Because x to the 3rd is where we started, and since we're dividing by an x, the very next thing would have to be a...
Oh, okay.
Right, because if I had x to the 3rd divided by x, it would be x squared.
This is kind of like multiple matrices. I thought it was harder than
Yeah, it goes really... It gets way easy if you use synthetic. I don't know why... I don't think this book even teaches synthetic, so... Okay, everybody good? Questions there?
No.
This would be our final answer. There was no remainder. Do you want to do another one? I heard a yes, so we're doing it. Okay, so you guess you can get started, or you can pay attention to the next one. Alright, so since it's x plus 3, we're going to do a negative 3 as our divisor. We're going to use a long bar again. Do y'all like that one? Take our coefficients. So our coefficients were 6, negative 6, negative 6. This is not a good, and a 6. It's a lot of 6s. I drop down my first term, which is 6, and I start multiplying. I get negative 18, same sign sum. I get a negative 24. I multiply that through again. Negative 3 times 24 is 72. Negative 70, it's positive 72. So now I have different sign difference, and I get a positive 60, what? 66? Good. Then I have negative 3 times 66, which is negative 198. And I have different sign difference, negative 192. So I definitely have a remainder this time. Since I started with the the exponent of 3, I'm going to have x squared. I'm going to have x. I'm just going to have a regular number, so I'm going to fill that in with a plus. And this is going to be negative 192 over my divisor, which is x plus 3. And that will be my final answer. Hopefully. So, they'll ask you a question like, is this a 0? If it does not go in there perfectly, it is not a 0.